All right, so we want to solve this log equation. We have log base 4 of 2x plus 1 equals log base 4 of x minus 3 plus log base 4 of x plus 5. Now, as we do a quick check of the initial problem, we notice that each term has a log expression in it, right? And that's actually pretty good, right? So the idea is if the log of one side, right, so let's say log base b of m is equal to log base b of n, right? Then we can conclude that m is equal to n, right? And this should be true, right? Because we have the same log with the same base. The arguments then should be equal, right? Now, before we can actually do that in this case, you notice that, wait a minute, there's two log expressions on the right side, right? So we should just combine these first, okay? So because of the plus, right, that tells us that on the right side, okay, we should multiply these together, right? So we can combine them into one log and multiply x minus 3 times x plus 5. We get x squared plus 2x minus 15 here. But you notice we have log base 4 of 2x plus 1 on the left and log base 4 of x squared plus 2x minus 15 on the right. So what can we conclude then? We can conclude that 2x plus 1 equals x squared plus 2x minus 15, right? And so essentially what we've done is we've converted from a log equation into this quadratic equation, right? Let's subtract the 2x. Let's subtract the 1 here. What do we get? We get x0 equals x squared minus 16, right? Well, this is going to give us two answers, right? We can factor this. So we're going to get as our answers x equals positive 4 and also x equals negative 4. Okay, but remember, you have to check these answers, right? Anytime we have a log equation, you have to check your answer. What do we mean by that? Right? When you plug this answer back into the original problem, we should not end up with a negative argument here, right? So when you plug the 4 back in, notice we get 9, we get 1, we get 9. So that works out, right? We don't end up with a negative value. But notice what happens when you plug the negative 4 back in here, right? We get log base 4 of negative 8 plus 1, which is negative 7. Okay? And we don't need to plug it in here because even if it just happens just once, right? What is log base 4 of negative 7? Okay, that doesn't exist. Okay? So what does that tell us about negative 4? It's not an answer, right? It's called extraneous. Right? So in this case, we're only going to have one answer. X equals positive 4.